Next off, we are going to talk about uniform ring or disk of charge. Okay, they are exactly done the same way, so we're going to do them together. First of all, I'm going to talk about, well, the answer is going to be the same, so we're going to just do one of them. So I'm going to talk about a ring conductor. Okay, so what does a ring conductor look like? Well, a ring conductor will look something like this, right? So there is a ring conductor, and it has a radius r, and it has a total charge q. Okay, so now our job is to find E at point P along z-axis. Okay, so this is the point P directly above, and I have to find the electric field due to this conductor at point P. Okay? So first off, I am going to, again, divide it into dq, a small volume element dq. Okay? And that small volume element is going to be, since this is a disk, it is going to have ds, right? It's going to have a small, and that corresponds to angle theta. Okay? So, dE of this segment is going to be 1 over 4 pi epsilon naught dq over z squared plus r squared, where this is z, this is r, and this is small r. Okay? This small r is actually equals to r squared plus z squared square root, just so you know. So this directly corresponds to only the z component. And by symmetric arguments, we will see dy and dx will equal 0. Okay, just like we've done it before. Okay? Now, what do we know? We know that dEz is equals to dE cosine theta. So this dE can be plugged in here. dq over z squared plus r squared. And cosine of theta, if this angle is theta, then cosine of theta will just be z over z squared plus r squared square root. Okay? Simplifying, we will get k z dq divided by z squared plus r squared 3/2. And that is going to be dEz. In order to calculate the total E, what do I have to do? I have to integrate both sides. Which means I'm going to get E on this side, kz divided by z squared plus r squared 3/2. Integration is going to be over dq, which gives me E equals kz divided by z squared plus r squared 3/2 q. Okay? And that is going to be the E field due to a uniform ring or disk of charge.